Hello everybody and welcome to this sneak peek preview. My name is Pedro Silva. I'm a member of the Acryl Data team, and today I'm going to talk to you about a little something that we're working on, which is removing Schema Registry as a requirement as a standalone feature within DataHub. So to give you a little bit of context as to why we're doing this, first of all, it's a highly requested community ask. We actually have, I think, around 22 upvotes for this feature alone, which is to remove Confluent Schema Registry, which is our current dependency, from DataHub completely. And the objective here is to reduce the operational overhead that you have when deploying and managing DataHub, since this is a standalone component that you need to manage. But once this feature is out, that will no longer be the case. Furthermore, it actually allows potential adopters from using DataHub because it completely removes the need for a Confluent license to run DataHub at all. In the past, we've had some members in the community who used open source alternatives to Confluent Schema Registry, such as Carapace, but with this feature, that will no longer be the case. As a fourth and final bonus, this also opens up the way for DataHub to become a full-blown schema registry replacement of its own. So rather than you deploying Confluent Schema Registry with perhaps a license that you don't like, you can actually deploy DataHub completely as standalone with all the features that it already brings as a data catalog and a metadata management system, and also use it as a schema registry for your Kafka and Kafka compliant systems. So as a first step, what we're looking to do as of right now, and this is January 2023, is to give DataHub's internal Kafka consumers and producers the knowledge on how to process or how to serialize and deserialize DataHub's internal messages. And all of this within DataHub itself without the need for any extra components. So how shall we do this considering this objective? Well, the first thing that we want to do is for full backwards compatibility, we will actually implement Confluent's OpenAPI spec for the schema registry. By doing this, we're essentially implementing the exact same interface that Confluent provides, which means that we can use the existing Kafka serializers and deserializers without issue. So it's a simple swap and replace, and everything else should work just fine. Bear in mind, though, that this is not meant to be a fully compliant schema registry implementation for now, and it will only work for DataHub's internal messaging formats. However, that is subject to change, varying on how well this feature is used and the direction that both the core team and the community want to take DataHub in. So how is that going to happen? Well, for a very high-level overview, suppose that you currently use DataHub to ingest metadata, right? In your processing metadata, you want to search for it, you want just to use it as you have been doing with DataHub so far. Well, the existing pipeline, what happens is you have some events that you want to ingest into DataHub with the metadata that you want, and that somewhere down the pipe goes through an API endpoint which calls ingest proposal. Essentially, we take in your event and we generate an MCP, a Kafka MCP event from that. However, this ingestion proposal process has a requirement to the schema registry, which means that the serialization logic will have to go to the registry, figure out what the format for the MCP topic is, and from there serialize the message correctly. Obviously, this then gets sent out into Kafka, and finally it gets processed by our standalone consumers, which again need to know how to deserialize that message in order to handle it, and that also requires a registry. So what we're going to do now is we're essentially going to take the OpenAPI spec, we're going to implement it within GMS as an HTTP, as an OpenAPI implementation, and with the knowledge on how to serialize and deserialize these topics internally, we are going to simply replace that external component into an internal one.